if you started with a log base 2 of x equals y, and we wanted to rewrite that as an exponent, we would have the base raised to that power is equal to that argument. Yes? Right? We're just going backwards. So if I go backwards, the base of the log is the base of my power. What the log is equal to is my exponent, and the argument is what I equal. So if I adapt that here, then I should have the log of 7. What I equal to is my argument, and my exponent is what my log is equal to. So like I said, it's a little bit of a switch because they're making you go the other direction, but it follows the same process. All right, number 2. How do I do number 2? I have to make my bases the same. So what's the base that I can create? 10. So 10 stays. What replaces the 100? 10 squared. Good. Good so far? All right, now before you can drop bases, you have to take care of this power raised to power. So you're going to have to distribute your 2 inside. So 2 times the 3x gives me 6x minus 10, because 2 times the 5 gives me 10. Because we need to do it. Good so far? Now that my bases are the same, I can drop bases, which means we can set the exponents as being equal. Again, the rule for that is you have to have one base on each side. They have to have the same base in order to drop them. Questions there? All right, so then from here, how do I solve it?
Minus the 6x.
Minus the 6x. Gives me a negative 4x equals negative 10. How do I go from here?
Divide negative 4 by negative 10.
I can reduce that, and I get 5 halves for my answer there. Questions on that one? Take out the solving worksheets we had yesterday. Technically, there's 3 of them. There's 2 solving exponents and the solving of a log. Yeah, but you'll have to eventually staple your work to the front page onto it.
This is good. Do after lunch.
It would be late.
I would like that, thanks, I will. And do it after lunch.
We got that ready? If you are on this side of the room, you're going to exchange with somebody on this side of the room. And if you're in the middle, you get to.
Why don't you just exchange right next?
Yeah, okay, so, start.
Let's go, let's go.
Exactly.
Yeah.
I guess so.
Oh, we did really great that week. Yeah. Thank you.
I really need a seating chart if this is the amount of homework that's getting exchanged right now. This is not good at all. Write down your name at the bottom in a pen, marker, crayon, highlighter, not yellow. Are we ready? We are going to start on the first of the solving. So So number 1 is -3/2. Number 3 is -2. 5 is 2/3. 7 is 2. 9 is 0 and was in our notes. And 11 is 1/2. Moving on to the other exponent. I don't care how they rounded, although they should have rounded 4 places, because that's what the worksheet told you. Number 1 is 2.5789. 3 is 1.7712. 5 is 3.8540. 7 is 2.5646. 9 is 0.0951. 11 is -8.0172. Going on to the logs, number 1 is 3. 3 is 7/9. 5 is -1. 7 is -2. 8 is -100. And 11 is -6. Go ahead and give them their papers back.
Okay, that's your total for all the pages. I could,
As long as you could tell which is which.
Ms. Kurtz has it too.
Alright, I want you to take out the log properties that we did a while back. So the more log properties, and I want you to staple that to these 3 worksheets. I have the stapler coming around. Hopefully we can staple that pretty quick because we need to go over ones and then we're going to turn that in. I've already done a lot for you off of those 3 worksheets, which means I'm only going to do 1 now. If you had to pick one off of those 3 worksheets, what one would you pick? Right?
7/30.
Any other nominations before we do? Yep.
Number 3 on the first one.
Any other nominations before we vote on the one we're gonna do? Any others? No. 9 on the first one. Are we good? You might want to scan those 4, because we're going to vote. You have to vote for only one. Are we ready to vote? All right, who wants on the third one, number 7? Number 3 on the first. Number 9 on the first. Number 9 on the second. So anybody who cares voted for the other one besides me. All right, so number 7 on the third. All right. Does everything have a log? No, which means I need to get the log alone, so what has to move? 10. The -10. How do I move the -10? Add 10 to the other side. Good. That gives me log base 3 of n plus 3 is equal to 0. At this point, is my log by all alone? Yes, it is, because remember, this is all part of the argument, so I can't touch that. If I have a log equal to a number, we can rewrite it as an exponent. Rewriting it as an exponent, we start with the base. What's the base? What am I going to be raising that 3 to? And that's going to be equal to? Perfect. Good so far? What is 3 to the 0 power? And then how do I solve for n here? Don't forget on these logs, you always have to check them. You go all the way back to the original log, plug in the -2, and you need to get a positive number on the inside, which you do. So that means you can keep that -2 as your answer. Go through on all 4 papers. So you have the more log properties, you have the 2 exponentials, and then you have the logs for solving. Tally up however many you missed out of all 4 of those sections. Are we done stapling at this point? Once you have your tally of how many you missed out of all of the worksheets, go ahead and pass them to the front, please. Homework papers. They have to be submitted all together. Any other homework? Staplers back there.
Right here.
Okay. On this worksheet, you are going to be doing problem number 19, problem number 23. On 19 and 23, those are kind of weird. They are asking you, do you see how like 19 says the ln of x equals 27, and then you have a comma, x equals e to the 27th power? Yes? They're asking you to replace the x and the ln with e to the 27th power. So you're going to replace the x with that value, and then you are to prove using your properties that the left side is equal to the right side. I do not want you to simply just plug it into a calculator and show it that way. You need to do it by properties. How does the left equal the right-hand side? I will tell you that this will be off of the initial property list that I gave you a couple weeks ago. Okay? Once you're done with 23, then you're going to be doing problem number 25, 29, 33, 37, 41, 45, 49, 53, 57, and 59. your task for today, I'm gonna put you into groups. In your groups, I want to see you working together on this so that you can try to make sure that we're understanding it, things like that. And then tomorrow I will let you work by yourself. But your goal is to get as far as you can on this so that tomorrow we can grade this at the end of the hour. But be careful. Are we still listening to me? Are you sure? Be careful, tomorrow's a car day, which means we're short, right? We have a warm-up, so in all honesty, you probably will only get about 15-20 minutes if we want to grade this tomorrow. If we can't grade this tomorrow, then it's going to eat out of your quiz time. In other words, instead of having the full hour for the quiz, we're going to have to grade real fast, turn it in real fast, and then do the quiz. Okay, so like I said, I'd like to grade this tomorrow if we can. So your goal is in your groups to get as far as you possibly can, but I don't want to see you working by yourself in your group. That's kind of pointless. Okay, so work together, talk it out together, help each other out, so that we can finish this tomorrow. Make sense? All right. Okay. Are you ready? 3, 4, exactly 5, 6. You can say 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Numbers get together, form your tables. I want to see you talking, working through this. Where do you want to sit?